When banks decide whether to approve a loan, they're weighing many factors: your account balances, your credit history, even your employment length. However, those with bad credit or no credit are often disallowed lending. In response, banks are exploring ways to extend lending to those who don't meet traditional credit criteria. At the same time, they must remain cautious and aim to limit their risk. Our project centers on building a gradient boosting model to predict credit approvals. You can think of it like a team of short-term learners. Each learner looks at a small grouping of data, makes a quick guess, and moves on. Then the next learner comes along and reviews the previous guess and gathers more data to make its own guess, refining the mistakes of the previous until we get a final, more powerful prediction. We worked with a balanced version of the German credit dataset from the UCI Machine Learning Repository, which includes features like loan duration, credit amount, and checking account balance. We used 80% of the data to train our model. The remaining 20% of the data was for testing, so we could gauge our performance on unseen examples. But the key to success wasn't just picking a single configuration. We systematically tried different numbers of leaves, different learning rates, and different iteration counts. Why? Because gradient boosting can be temperamental. Nudge the learning rate too high, and the model can overfit. Use too few iterations, and the model underfits. This is called hyperparameter tuning. Our final configuration gave us an accuracy of about 70% on the test set. That's a solid baseline for credit approval predictions, especially for a relatively small dataset like the one we used. These numbers matter because they show that we can classify credit approvals correctly 7 times out of 10. For a real-world scenario, this could reduce the risk of bad loans and help allocate credit more efficiently. This solution aims to improve how lenders and borrowers interact. Our model demonstrates a practical solution. It is scalable, interpretable, and efficient. It is scalable because gradient boosting handles both large and small datasets well. It is interpretable because we can dig into which features most impact approvals. It is efficient because we can integrate it quickly using a machine learning.NET pipeline, providing results with minimal overhead. You might be asking, can we push accuracy beyond 70%? Absolutely. Adding more data and refining hyperparameters can significantly boost the model's performance, while trimming away at less impactful features can further hone its accuracy and efficiency. Additionally, our model would still work if the user has never taken out a loan before, because it relies on broader features such as checking account balance, age, current employment length, and savings account balance bonds, rather than depending only on past loan data. In this segment, I'm entering a sample credit request using the form on screen. The dataset behind the model was originally collected in Germany, so currency amounts are marked in Deutschmarks instead of US dollars. Each field has a coded value, like A11 or A12, representing different categories for checking account status, credit history, and other factors. Now that I've entered my details, I'll click Predict to see what the model decides. The result shows approved, along with a probability and a raw score. The score reported by the model is a raw, unbounded value indicating how strongly the algorithm leans toward approval, a positive number, or denial, a negative number. This score isn't directly interpretable as a percentage, but serves as the basis for calculating the probability. In other words, the score reflects the model's internal confidence before it's mapped onto a familiar 0 to 1 range you see under probability. A higher positive score typically translates to a higher probability of approval, whereas a lower or negative score lowers that probability. This outcome reflects patterns learned from the German credit dataset and doesn't guarantee real-world lending decisions. The model was trained on a balanced subset of around 600 records, so its recommendations are for demonstration only. So that's our story. By using gradient boosting and a bit of tuning, we built a model that automatically learns from past credit data, leading to an actionable solution for financial institutions. For us, that translates into a 70% accuracy solution, with the promise of even more improvement on the horizon. Thank you for watching. We appreciate your consideration and look forward to refining this model to unlock even greater predictive power.